Let's talk about bivariate analysis. But before moving into bivariate analysis, it helps to briefly ground the idea of univariate analysis because the difference between the two is really about how many variables you are looking at once. So let's look at univariate analysis. We've talked about this already, but I've not really put them under the term univariate analysis. So univariate analysis is the simplest form of quantitative analysis. It focuses on a single variable at a time. For example, if you collected data on student stress levels, univariate analysis would describe that one variable on its own. You might calculate the average stress level or show how many students fall into low, medium, or high stress categories, so frequencies, or look at how responses are distributed across a scale. The goal here is not to find relationships yet. You are just trying to understand the shape of one variable. What does the data look like on its own? That is univariate thinking. Well, now that that foundation is clear, bivariate analysis becomes much easier to understand. So let's jump into it. Bivariate analysis is what happens when you start looking at two variables at the same time. So bivariate, variate variables, by, two. Their goal is to understand whether there is a relationship, difference, or a pattern between them. Instead of asking, what does this variable look like? You start asking, how does this variable behave in relation to another variable? Let's take an example. Suppose you are studying academic performance, right? You already have one variable, academic performance. Now you introduce a second variable, study hours or study time. Bivariate analysis allows you to examine whether students who study more hours tend to have higher academic performance. Now, depending on the type of variables you are working with, this analysis can take different forms. If both variables are categorical variables, you might use a cross tabulation. For example, gender and pass or fail status. So you are looking at academic performance, whether the person pass or fail. That is another category. Then you also have gender as another category. Here you have to create a table that shows how many males passed and how many females passed. Then you look for patterns. If one variable is categorical and the other is numerical, you also might compare group means, the mean. For example, you compare the average stress levels between male and female students. So you are no longer just describing stress here, you are just comparing stress across groups. That is bivariate. And if both variables are numerical, you might use what is called correlation analysis. For example, study hours and exam scores, they are both numerical. Here you are looking at whether the two variables move together. Correlation, do they correlate? Do they move together? Whether maybe increases in one variable tend to be associated with increases or decreases in the other variable. And what connects all of this is just the same idea. You are no longer focusing on a single variable in isolation. You are exploring how two variables interact within your data set. And an important limitation to keep in mind is this. Bivariate analysis shows patterns between two variables, but it does not automatically explain why that pattern exists. For example, if you find that students who study more tend to perform better, bivariate analysis will show that relationship, but it will not tell you whether study time is the cause of better performance or whether another factor is influencing both. That is why bivariate analysis is often an intermediate step in quantitative research. It helps you move from description to relationships. And from there, more advanced techniques like regression can help you control for other variables and build stronger explanations for these relationships. So the simplest way to think about this is this. Univariate analysis looks at one variable at a time. Bivariate analysis looks at how two variables relate to each other. One helps you understand your data and the other helps you start understanding connections within your data. And once that connection is clear, the rest of your analysis becomes much more meaningful.